Hello everyone, my name is Pramod Lal and welcome to my YouTube channel Code Insight, where I share my knowledge in the data science and AI. And today I come with one of the interesting series that is the second series of the RAG, and we are going to talk about the hybrid RAG. How hybrid RAG is different than traditional or naive or basic RAG. So first series I already built an utility and have already created a video and share with you guys. So go through it for first series if you have not gone through it, and if you have go through the first series, definitely this second series, the hybrid drive, will better. You will get a sense very quickly. So stay tuned with me. I'm trying to cover this one in next 20 to 25 minutes. And then reason being, I develop an utility, ecom based utility that's I have at the end of the session. I'll give a walkthrough of that also. All right. So, what is a hybrid drag? So, before that, I'll go one step back. We talk about a native or neighbor or basic drag. So, even though I'll go one more step back, and it's a minus one step. So, that would be your traditional LLM without the rag. So, what is the challenge with the LLM? Why rag come into the picture, right? So even all this I have already discussed in the first video of the RAG series, but giving the basic overview. So traditional LLM without RAG, knowledge cutoff date. We know, I mean, for every LLM, there is a cutoff date. I mean, the date when the LLM trained last time on the data. Hallucination, yeah, hallucination is the major concern with the LLM. No private data. Yes, LLM does not have access of your company specific data or your data. Static knowledge means new information without the retaining. Yep. So this is again one problem with the LLM, and the no source attribution, so cannot cite information sources, right? So that's the problem with traditional LLM. Now, so example, what is your our return policy? Generic or no, wrong answer, because the LLM does not know about your company return policy. So whether it will give you the generic answer or wrong answer, so that could be your hallucination. Now, then, what is the RAG? We talk much about in the first raise. So, RAG stands for the Retrieval-Augmented Generation. It's a three stage. One is the retrieve, augment, and generate, right? And then a traditional RAG work. So, user query, retrieve relevant document with the help of the vector search, combine query plus retrieve context, send to LLM, whatever the LLM you can use. It's up to you, and on the basis of that, LLM generate the response, and that response is given back to the user, uh, right? Now the example flow: query, retrieve, context, LLM, response. So five steps. So here you can also see. So traditional RAG limitation, you can go in my first race video where I have given the detail about the limitation. But in the summary, single strategy approach, only use the semantic and vector search. We'll talk. I already talked much about the what is the vector and semantic search. No optimal for all query type. A struggle to exact match like ID, date, and number. Yeah. So yep. And poor performance on the structured data, because your ID, date, number could be the part of the structured data also. So the poor performance cannot handle complex filtering requirements. So basic of the understanding a RAG. Now let's jump to the limitation, right? So as said earlier, RAG, traditional RAG, only use the vector search for all query, right? So that is the big challenge with the traditional RAG. So problem, one size fit all, no optimal for all query type. Performance low for exact lookup, ID and order. Cost, must create embedding for all data. So here is there is a big cost associated to build a traditional RAG based system, because you have to embed and chunk all the data there. For example, I'll say, so order number 1, 2, 3, 4, 5. So convert this statement into the vector, search 50K orders and find the similar that is matching with your vector, right? So response is 800 millisecond and cost $0.3, and accuracy would be the 85. So here, L traditional and LLM has a limitation and challenge. That's why hybrid RAG come into the picture. So now talk about the hybrid RAG. So hybrid RAG, an intelligent solution. So hybrid RAG extend traditional RAG by combining multiple retrieval strategy intelligently, right? It's not just combination of the all approach for the retrieval, but that's multiple combining multiple retrieval strategy intelligently. That the key things. selecting the best approach based on the query type. So now use multiple retrieval strategy intelligently. So here the solution that I have built, I am using the three strategy. One is the vector search, that the semantic search. What's your return policy? Look for the relevant document and find the vector matching with this one, give response to the user. Filtered search, let's say if you want to look for the so order number 1 2 3 4 5, so this instead of looking applying the similar vector search here or similarity search, directly look up into your database, right? Full text search, it's keyword plus facets where laptop under dollar hunt thousand, so keyword plus filter. So right tool for each job, so better, faster, and cheaper. We'll get to know how hybrid drag is better, faster, and cheaper. Well, so the strategy one is the vector search. Vector search, definitely you have to implement in your traditional or navRag also. So how it works? So best for the conceptual question document search. How it works? So document search. So I'll giving you an example. Like I have a PDF. I have a PDF like your customer. What is the name of this PDF? So this name of the PDF, let me go back to this one. So data PDF, right? So I have used these different types of the PDF: customer fake, product log, return policy, shipping policy, and warranty. So here, if you are looking something from this PDF, then here we are applying the vector search or semantic search. So that's why it's saying convert best for the conceptual question document search. How it works? Convert text into numerical vector, and I'm using here 13072 dimension vector embedding. In the flag series one, I have used the vector 1532 dimension for the vector embedding. Cosine similarity, whoever the best matching will give the result. Find semantic similar content, so return semantic similar content here. Best for the natural language questions, conceptual query, paraphrase question, content understanding. Example here: comfortable footwear for walking. So what exactly they are look for? The product with ergonomic shoes, walking sneakers, comfortable boots. See, the user is asking comfortable footwear for the walking, but the find this product with ergonomic shoes, walking sneaker, and comfortable boots. So they have these three words, these three words are very similar to, they have some similarity in this query part, right? Why? Understand semantic meaning, not just the keyword, right? So see, the keyword would be the different, but I said earlier, this the comfortable footwear walking having very similar vector embedding with your walking sneaker, comfortable boots. So technically, how this has been implemented: embedding, you're embedding into, I said earlier, 3072 dimension, and then let me go into the 100. Okay, yeah, let me go into the 100. So embedding into 3072 dimension, and similarity search, cosine similarity has been applied. So this all about for the this one for vector search. Now move to the next one. So next one is your filter search. Let me go back to here. So this is your filter search. Here, best suit for query with ID, exact field matching. Right? How it is work? Extract ID, filter value from the query, build OData filter expressions. Very similar to the SQL where statement. Those who were familiar with the SQL where statement, they easily able to understand the OData filter. If not, then be you will get by sense by the end of this slide only. So direct index lookup, return exact matches only, right? Return exact matches only. Best for the lookup by ID, customer ID, order ID, product, numerical filter like price greater than 100, quantity less than 10, date range, order after so and so date, and category having as a status filter. So example here. So what is the customer 003? So filter, they will make a filter customer ID equal to customer 003. I'll show you. So here, if I go into here, so you can see this is the column is customer ID. That's why you can see here customer ID equal to customer 003. So why exact match needed? Definitely exact match needed. We can't provide the customer ID even 03 audit, right? So that's why exact match needed. No semantic search required. So technical implementation, your OData filter, address state equal to NB and total amount greater than 500. So this is the for different case, like customer having, if you look here, the customer who belong to the state NB, and so far total order amount is greater than 500. But for this one here, your OData filter would be like it's given already here, customer ID equal to cust 003. So this about the filter search. This is the strategy 2. Now the strategy 3 is the full text search. That's a keyword for us, face it size. So best for the product search with the multiple filter. So if we are applying the multiple filter, then we need a key full text search. So how it is work in the background? So tokenize query into your keyword. So then apply facet filter, price, category, and availability. I mean, many type of filter you can apply. BM25 ranking algorithm for relevant, and return rank result. So for example, wireless headphone under 100K stock. So see how the keyword is there. So wireless headphone filter. What filter is applied here? It's a price less than 100 and availability in stock. Performance 100 millisecond, cost is 0.5, accuracy is 99%, cost is why 0.05, because there is no vector embedding is required. All right. So now here we have a tabular comparison, traditional RAG versus hybrid RAG. So aspect query type, we know I said earlier, vector only. Here three strategy we already discussed, your vector and then the filter and then full text search. Improvement 3 times faster than traditional RAG. The speed is 100 millisecond for the one response. Here you will get the response in the 250 millisecond, 3.2 times faster. Cost and query, it's for one query for one user response, one query and response, it will cost $0.27, but in hybrid drag it's 0.009. Reduction, you can see the improvement 67%. Accuracy is here 85%, here 99 plus. And structured data, definitely. So your traditional RAG will fail for the structured data, and hybrid RAG, this is the excellent, right? So why hybrid RAG is superior? So query type, traditional, and again, it's a tabular comparison. So if the user is asking what is the return policy, you will get a good response even with the vector, because this is coming from your PDF or here vector search has been applied. But the hybrid RAG will give the excellent one. Order customer 003. So here it's a filter search, right? So here definitely it would be poor performance, and hybrid drag, definitely it would be the better. So these are all the few examples, so why hybrid is superior than the traditional. Now the architecture by hybrid drag, it's a user query classification. Here the key things is the intent detection, when to know which should when to know basis on the intent, whether vector search required to be applied, whether filter search would required to be applied, where the product search, full text search required to be applied, right? So context retrieval. So you can see the query classification is a policy and fake question, go for the vector search. If the lookup by ID and status, go for the filter search. If the product search, go for the full text search. If the complex query, combine multiple strategies, right? So key benefit of the hybrid RAG: accuracy, speed, flexibility, cost effective, and scalability. Well, I'll share this PPT so you can go through this in detail. So traditional RAG, single easy, vector only, hybrid RAG, multi-strategy, right? That we already discussed. Now, what is the flow of this RAG system? Let me give you the overview of the RAG system also. So let me run this one. So this is my solution structure. Okay, it's a hybrid RAG Azure, because I have used only all the extensive resource of the Azure only, no freebie, no AWS. So I'm thinking to build a very similar solution in the AWS itself. So this rate will be more AWS, not in AWS, in Azure. Sure, let's get it loaded first, and then meanwhile I'll come to the this PDF. So here, a structure is the hybrid drag structure. It's a two phase. One is the indexing phase, another is the query phase. So indexing phase, we'll see here, we have a PDF and CSV. I have given you a sense here only. So these are the PDF and this is the CSV. And then we have how the things is working here. Let me go into the 100%. So we have a PDF. So PDF indexing phase, we have dealing with the two type of data. One is the PDF and CSV. So document loader and text splitter, chunking, and then a vector embedding, then a storage into the AI search, having the six different index. I'll let you know why six different index later on. CSV, and then again here CSV directly storing into here in the Azure AI search. There is no indexing applied here. Sorry, no embedding is required here. Now the how the chat, once the user interact with the chat, what would be the overall flow? So user query, and then let me go to the 100% only. So user query, it's a query analysis. Then what kind of strategy detection, your extract keyword detection, detect ID or filter, classify intent, route to the strategy. Which strategy? It's a vector search, filter search, and full text search. Discussed in a hybrid. In the solution, this solution I have implemented three different type of search mechanism. Top K content, top K result, retrieve context, look for the top K, and based on that, let's go to the Azure OpenAI GPT 4.0, that for the prompt building, right? Whatever the user given by the query and whatever the top K return by this after the vector search, returned by your vector database, passed to the LLM with proper crafting of the prompt, and then the LLM give the response, and that response is given back to the user. So that's the overall flow. So pipeline, that's the overall pipeline, and then we have this one, the application and data flow kind of thing, and we have the RAG architecture. In the RAG architecture, let me go a little more. So here you have a UI layer. UI layer, I'm using the Next.js, and then we have API route layer doing the different operations. So chat for the API route for the chatbot, and API for the product, API for the order, API for the return, API for the dashboard. Hybrids here, the hybrid RAG intelligent here. I mean, we should know when vector search, when full search, when filter search would be get applied. Context processing, response generation by your GPT 4.0 model I have used, right? Now, document, I said earlier, we have a four index here. So why four index here? So these are one for the document one for the customer, one for the product, one for the order, one for the inventory, one for the return index. And data storage, like the PDF, I am not storing entirely into the this one Azure Search AI Index. So actual PDF is getting stored in the Azure files here. That's why it's given here. Table storage, legacy CSV data, Azure storage account, file uploading, processing, right? So this all about the technical architecture, and then application insight, request telemetry. Yeah, these are the things you can apply for the monitoring. This is the data flow diagram. It's a complex one, so I'm not able to capture or wrap up this video in next 10 to 15 minutes. So now the Azure, what AI services I have used. So let me show you the application. This is the application that I have built using Next.js as a user interface, and Azure services like OpenAI, Azure AI services, Azure File Share, implementer using, I have used the OpenAI GPT 4.0 model. All right, so now let's go to the Azure AI services. What I have used, I said earlier, it's Azure OpenAI GPT-4o for generation, and text embedding, three large model for the text embedding. Azure AI searches, six index with the hybrid capability. Already told you what all six indexes are. Azure storage, file share for the PDF one, application Next.js, and UI part, TypeScript for the type safety, and then data source, 850 plus, but in fact I have not used. I'll show you why I have captured this one later on. Vector search, and what is the real world use cases for this one. So vector search example, what is your warranty policy, how to handle the damaged items. So these we can say here in the customer a fake kind of thing. That's why for vector search, if anything related to this, we will go for the vector search. Now the search Filter search, if anything come with order with the customer, order for the customer C12345, so this will go for filter search. Now the full text search, that's giving the little bit a complex, like laptop under $100, wireless headphone in a stock, so electronics on sale. So this kind of will go for the full text search, right? So full text search, I'll go back one step back here. So here is the implementation of full text search. Full text search. No, this would be your full text filter search. Yeah, no, sorry. This is the full text search keyword for us. Face it. That's why full text search applied here. All right. So application data source we discussed already, and vector search, full text search, and mix search, where we have to apply the mix kind of along with the vector search or the keyword search. So that is the mix. I mean a combination of three as well. You can understand. Customer experience, instant accurate answer, hybrid search definitely giving a better answer within in 1.8 seconds. So 24 into 7 availability. If you host on online platform, it would be your 24 into 7. Consistency information across all channels, because information is coming from the relevant data source, whether from the PDF or from your CSV. So always time data information will be consistent. Operational efficiency, business value, you can look into the detail later on. So operational 67% cost reduction at comparison to traditional RAG, 3.2 times faster response time than traditional RAG, 99 plus accuracy with some challenges. Business value, reduce support ticket volume by 50-40%. Yeah, definitely you can, as of now, if any issue, if someone user want to ask call to support help desk, and then will ask what is the my order status, someone receive a call and log a ticket. So it's saying instead of that, user can directly interact with the chatbot. So it's definitely reducing your 40% of the ticket volume. So that's the case, kind of thing. So indexing 8050 PDF can be indexed within 45 minutes, right? So if manual processing required to process or get the sense of the 850 PDF, consider it will not take less than 1 week. But here with the chatbot, we can process 850 PDF in 45 minutes. And 50K CSV record can be indexed in 8 minutes. So consider how robust this application. So let me go back to 66%. So key takeaway, I mean, RAG solve LLM limitation by grounding answer with your data. Your data mean your internal data. Traditional RAG uses only vector search, so it's sometimes become inefficient. Hybrid RAG, it's an intelligent route with three strategy. We discussed a lot in detail: vector, filter, and full text. Result 3.2 times faster, 67% cheaper, and 99% plus accurate. All right, so let me go back to this one. So what all services I have used. So this is my Azure portal dashboard kind of thing. Not that, yeah. So here you can see so far in this I have used Azure AI services, then Azure OpenAI 4.0, then we have a storage account, right? So storage account files here to store PDF kind of thing. Let me go to the demo of this solution. So this is your dashboard, and most of the company use very similar kind of the dashboard. Along with the bottom right, you will see the pop-up for floating chatbot. So this is the chat window where user can interact with this chatbot. So let me go to something very here. I'll ask this chatbot here, what is the email? See, this is the customer detail where we have the basic information on the customer. This is the dummy data, not the real one. So I'll ask here, what is the email ID of this customer? I'll go back to the chatbot and ask here, what is email of, it's a typo. In fast, it's a pen typo for very, very small thing. So email of customer, this and this. So customer 007, we are looking the email. Let's see, the email of the customer 007 is the Robert Taylor. Let me see if this is the correct. Yeah, this is the correct. Let me ask one more question, like what is the customer ID of this? Jane Smith. So let me ask quickly. So what is customer ID of email? I'll pass this one, right? So it's a 002. Let me go back to this one. So for this structured data, we are getting the good response, right? And very quickly. Now I'll ask some question that based on your PDF. So I'll ask here, how how long do I have to return an item? So let me ask this question to the chatbot. Here vector search is applied here because here you can say the okay, so okay, this all given the return policy, right? So I'll be more specific here. For each item return a specific, yeah. So chatbot got confused, right? For which item I'm asking for the return policy. That's why. So this has given whatever the item, what all item I have, they have given the return policy of all item. Let I should be a more specific. I'll ask something more specific, right? So what is the price of this one? I'll ask this one, right? So as per this one, price is USB-C charging 12.99. I'll ask what is price of. Okay, so 12.99. I see the price of this is the 12.99. So this we have, see, we have implemented a hybrid RAG here, implemented three different approach to implement the hybrid RAG. And on the end of, I promised earlier in the beginning of the video, at the end of the session, I'll do the walkthrough or demo of the one application. So I have a dummy data, and this all data is already stored here in Azure AI Search chatbot, and basis of that we'll see we got the correct response, right? So I'll show you. I'll look for here indexes. So this is my you can see how all together we have six indexes as said earlier. So chatbot is definitely working fine, and we have just seen the response. So, and application wise, I'll say earlier, this is the hybrid Azure RAG Azure, because I'm exclusively use the Azure resource that I've given the Azure one, but I'm planning to develop a hybrid in AWS area also. And we have used so many things here like Next.js. It's a detail. It's hard to discuss technical implementation. I'll push a code on the GitHub repo, go through it, and if you have any question, please feel to knock me. I'll happy to answer your question. Thanks for watching your video. And this application very much smart, efficient, and capable to serve a small base e-commerce application. If someone need that kind of application, please reach out to me. Thank you. Thanks for watching this video. Stay tuned. In the next series will be based on the agentic AI. Thank you. Let me stop the recording. Thank you.